Hello, everyone. Sorry I'm dark. I usually have lights here. They are not on. I can tell you why in a bit. Let me hop over to the right channel on the Discord server. Hello, DCD. Pause my preview. How's everyone doing? How's it look? Welcome, welcome, welcome. I realized, like, as I was setting up, I was like, oh, I didn't get this thing or that thing set up. So let's jump in. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python designed to run on little tiny computers called microcontrollers. Here's an example of a board here that Adafruit makes. So Adafruit makes development boards and kind of platforms for people to build stuff on. So this is a Feather S3, got a screen on it, and then underneath this like shield is a little chip that has a whole computer in it. You plug into the USB, which is here, you get a little CircuitPy drive, and you're able to edit the Python code that runs on this device. Adafruit makes open source hardware and software out of New York, and I work for them here in Seattle remotely. So I work on the software side mostly, but I have lots and lots of dev boards. I'm a little bit of a collector. So this is Deep Dive. I should say, if you want to support me, you can go to adafruit.com, purchase hardware there. They pay me to do these streams. They pay me to work on CircuitPython. They're great. Great company. Open source is the way to go. So CircuitPython is open source, and the hardware is open source as well. And there's lots of good content and tutorials and stuff off adafruit.com. So this is a deep dive. I do these pretty regularly on Fridays. If I'm unable to do it, Tim, who goes by Foamy Guy, does it for me. So thanks to Tim for doing last week when I was out of town. Tim now has his own deep dive spot. I think he's calling it deep dive still. Tuesday morning. So if you want to check out Tim's deep dives, you can check him out then as well. So this will be about an hour. I'm happy to answer questions. Otherwise, I just like to talk about all the sorts of stuff that I've been working on. So what are we going to cover today? What was I thinking? So I guess I'll explain why. I have two lights here that usually light my face better, but I got a new Wi-Fi router in the office here so that I could do better partition to different Wi-Fi networks, because my brain's spending a lot of time thinking about how to automate on the hardware testing, and Wi-Fi is a part of that. So I got a new Ubiquiti router. It does 6 gigahertz as well, so I'm excited for these new 5 and 6 gigahertz. So I don't think we have support for 5 gigahertz in CircuitPython proper yet. So that's something to add. And now I have a router that can test both 5 gigahertz and now 6 gigahertz as well. So, but the lights that are connected over Wi-Fi, I forgot to update. So they're not connected to the new Wi-Fi network. So I got to figure out how to do that. I tried to do that in the last 10 minutes and couldn't figure it out. So yeah, like that generally is a theme of like, and this has been the theme of my like CircuitPython 2026, is like really rethinking the way that I'm working. A lot more automated testing. So I've been doing, I've shown this on previous deep dives of like the native simulator from Zephyr as a portion of that. But I'd really love to have a board farm. So a board farm in my mind is like a bunch of development kits that are all connected to my network so that I can kind of automate testing to those things. I think it would be really cool. My current thinking on that approach is that it's going to be using USB IP. So what you'll do is you'll have another microcontroller, probably an ESP32P4, that you can plug devices into and then talk to those devices over USB IP. My main motivation for this is I had a lot of bad luck connecting directly to a Linux computer, like a Raspberry Pi. So the nice thing about using USB IP is that we can talk USB over our IP, and we actually don't need to connect it into the Linux kernel at all. We can if we want to, but we don't have to. So I'm really interested in that, and my brain has been thinking more about that as well. Hello, Biana. But yeah, thinking about just generally the way that I work, it's changed a lot in the first 3 months of the year, and it's just going to keep changing. So I know folks have watched other deep dives, and this has been a theme for all the deep dives this year. But part of getting my network set up is part of that. I also have a Mac Mini that I wasn't actually using that I intend on setting up as an OpenClaw. But before I did that, I wanted to make sure I could put it on its own network too. So I'm like slowly figuring that stuff out as well. That's the larger theme. And then what have I been working on? There are a number of things actually. If I go to my desktop, one thing I've been thinking about is my monitor setup. So I was just thinking, oh, I got this cool mouse tiler thing now, right? Where if I drag a window, it gives me an option of where I want to put it. And down here, I can put it where it sits just perfect where the stream sees. And then I was like, if I can easily place windows where the stream can see, why I have a big monitor, right? I have a big 40-inch ultra wide. And I have it in the top left. And so when I'm looking at the monitor that you see, I'm looking to my left. And I'm like, why don't I just place it in the top middle right below the camera that I've got? So this is me trying to use Claude to give me those options in the tiler. You can see that it's centered one region, but that region is not the region that I wanted. I wanted it centered horizontally, but not vertically. So I want my window that I'm looking at to be here. Anyway, so I was working on that, and then I also I have a couch here where I eat lunch, and I had my old monitor, and I was like, why aren't I using that monitor? And I watched some YouTube videos about people that had stacked it, so you could stack a second monitor here so that you can look up at it. And I was like, I tried it just briefly by putting my old monitor here and raising this one up. And I was like, I don't think that's going to work. But then I looked here, and I've got a gap between the window and my main monitor. And I was like, I think it should go there. So I ordered a monitor arm to put my old monitor here so that I could put OBS and the chats and stuff there as well. So really just rethinking my setup here. And the way that the way that I'm working is changing. So I'm constantly shifting between different tasks, and I love to automate. It's very obvious now the parts that would be nice to automate, basically the testing part. So I think I had mentioned it, but that I was working on updating CircuitPython to the IDF6. So espressif is a company that makes all these ESP32 chips, and they released their latest ESP-IDF6. They just released it, and I was like, usually this sort of thing is going to be I got to put it on the backlog. It's a ton of work. And I was like, you know what? With LLMs, the process that I would go through would be pretty straightforward. It would be tedious. And I think tedious is actually an optimal word for it too. And now I'm seeing that, oh no, I paused it, okay. What I would do is I'd read the migration guide, I would update the submodule, and then I would just basically fix all the compiler errors until it worked, and then I would test it on device. And I would read the migration guide to kind of have a feeling for it. And so I was like, that's something Claude can do. And so I've been poking and prodding Claude over the last week or two. And I've gotten to the point where I have everything building except for one stinking build that is a 2 megabyte flash and just has trouble fitting So I'm like 600 boards, 600 plus boards build, but there's just this one that doesn't build. So I linked some folks who were finding some performance issues in 10.1 to the IDF6 branch to see how it worked. But a lot of what I've been doing, like today or yesterday, I spent all day trying to get Wi-Fi working on some of the ESP chips. I think it was maybe the last 2 days, and I finally figured it out. Like Claude couldn't figure it out, but like kind of eventually got to the point where I was like, oh yeah, like we do this build system hack. So we don't use CMake from the ESP-IDF directly, and so we have to like clone or copy a lot of the make stuff or the build stuff into our makefile. The reason we use the makefile is because we use that same makefile stuff for other ports, except for the Zephyr one. But there's this really gross. They added this system that does initialization on startup, and the way that it works is that it puts pointers to functions in a particular memory section and then just runs them all in a particular order. The problem is that if you somehow omit one of those initialization things, you don't get an error. And so that ended up being the problem that I had with the Wi-Fi working with IDF6, is that I had some initialization stuff that wasn't happening because I didn't give it this linker parameter to get it pulled in. Which is just, I do not like that system. I wish that if something compiled and linked, that it would work, but that's not the case. I had the same issue with like weak functions, where like if you end up having a weak function and you call it, but you meant to call an actual implementation, like you don't find that out until runtime that you called the wrong one. So before I move on, why don't I just show that it works? So actually, you know what? I have the C6 going right now, I think. So if I do CircuitPython.local, heyo, we've got a C6 devkit m running, and this is using IDF6. It's just I had left it plugged in. So one way to use it is you could do code, and I know my password. It seems like it's working pretty quick, which is good. I'm going to open code.py. So this is what we call the web workflow, where you can do CircuitPython.local and then it resolves to the actual device. So it takes some of the board name and then some of the MAC address to create a unique CPy domain. So that uses MDNS, and then you do /code, and you'll get to the code.circuitpython.org interface. Oh, the Twitch stream is not up. I thought I started it. Oh, it looks like I forgot to check it. Hopefully YouTube didn't look too bad. It looks like Twitch should be up now. I think I have to like enable which places things are going. Are there post-linking steps that could detect the failure that causes Wi-Fi not to work? I think it'd be hard. I don't know. So what I ended up doing is I had this, I used an example from the IDF to just say like connect to my network, and it worked just fine. And so like me and the LLM had a reference to it. And it ended up like printing out like crypto stuff, the crypto stuff that is used in like the handshake at the start of the Wi-Fi thing. And then it was like, oh, it's probably not initialized. And like, I think I thought of the -u thing. I was like, oh, like I should have thought of this. And in fact, now I'm like, oh, I meant to tell the LLM to like write it down so that it's in the README of like, these are gotchas when updating it. And so that the next time because I knew this, like I've had the same problem when I've updated the IDF before. And LLMs are nice because they can rapidly go through stuff. And it's like, it's quite good at like I was posting like giving it like backtraces and stuff, and it knew how to use like address to line and stuff. I did find that I was building and loading on my own, and like making sure that the LLM like knew which version of the binary I was talking about, and that was like kind of tricky. So I'd really like, it's really got me thinking about like, okay, how do I get myself out of this loop? How do I get it loading code onto a device all by itself so that I don't have to do it? So it's still something. It's bound to be something. Like, we're gonna get there. It's just a matter of like when we get there and how much effort do we put into doing it. So I think it's not just me at Adafruit that's thinking about this. I'm sure people outside of Adafruit are as well. I listened to this podcast from Memfault, the folks, they just got bought by Nordic in like the last year, but they had an interview with a company called Bootloop, and they were talking about being able to do this. But they didn't go into very good detail. It wasn't super helpful detail. So let's just say from IDF6, we'll show that this works. We can hit save and run. And it says hello from IDF6. Print the fork repo owner and the commit ref into the build somehow. It's in our firmware file name, but not good enough. Well, that doesn't solve the problem of like I'm editing code. Like the crash log from espressif will give you the hash of the firmware. And that's probably the best, because like I'm talking about working in this like intermediate state where I'm like updating source files and things. But yeah, so if folks want to try it, I just made a draft pull request. I would love help testing this. So the other thing is that like I changed touch. The touch API up, I had it update to the new I2C API. So there's like all this like stuff that I've got to test, and I'm like, if I need to test this stuff, I should figure out a way to test it automatically, and then I don't have to ever test it. I don't ever have to manually test it again. So I'm like really thinking about how to get all this stuff set up. Okay, so if you go to CircuitPython pull request, and I just have this open draft migrating from ESP-IDF 5.3 to 6.0, and it's like largely all agent done. I need a robot hand. I was actually thinking about that, of like, how do I actually test the cap touch? How do I test the cap touch? Should I put a hot dog on a servo or something? Like, that could be actually one of the more challenging ones. I have, in one of my other tabs, I think in here, in this one, I actually was like brainstorming this stuff. So I thought, oh, okay, which CircuitPython APIs could I test by just doing a logic capture? So like these are the things that are write only. So NeoPixel, pulse out, I2S out, analog out, PWM out, protomatter, displays stuff. Like all that I could just test with the logic analyzer, because I don't actually need the device to reply at all. Which is good, because I changed protomatter and I was like, like I'm so lazy. I don't want to have to dig out an actual screen. And so it's like, oh, but if I had a logic analyzer that just did the capture, and then I ran some Python code that said like, yeah, that looks good, that'll work, or not, like, that would be super helpful. So Ty says, I've got many displays to test, so camera to Pi and QR codes next to each screen is my next step. Maybe I just drag one of those cheap styluses across the screen. Rubber band keeps it contacted. Simple servo. Yeah, interesting. I didn't even think about. Like, I care more about, and this is maybe the difference between what Limor and Tim are doing, where they're testing drivers for new hardware. So they were doing like proximity sensors and stuff. Whereas like, I care more about CircuitPython, and so I don't actually need a screen, right? Like I could just capture the screen output, the bits that are being blasted out, and then confirm that like I think it'll work or not. And then if there's cases where like it says it's good but it's not actually good, then I have to like update my test criteria. But this is also like the approach that I've been taking with the native sim, where one of the outputs the native sim is producing is a Perfetto file, which is like a trace file. And like I totally think that like I could have logic analyzer code that outputs a Perfetto file, and then the Python code analyzes it and says, "Yep, like that will drive an RGB matrix or not or whatever." So yeah, like so that's what this discussion. I've been doing a lot of like brainstorming with Claude for this. So okay, what are all the APIs I could test with just a logic analyzer? I don't actually need real hardware. And then it's like, oh, these are only read-only. So these four things, I would need some input into it. And then here's the things that are bidirectional. Yeah, so just brainstorming of like, in my brain I have like some test fixture, like an Arduino Shield hat or Arduino Shield that like has enough stuff on it that like I just put it on anything with that pinout, plug in like 2 USBs from it, and then like PoE Ethernet, boop, and now I've got this self-contained thing to do testing. Yeah, I'm thinking about that a lot. I'd also like to be able to do like pinmux testing. So like, let's verify that I2C works on all this variation of pin combinations. So yeah, thinking a lot about this. Thinking about like what form factors to support, and like generally the Arduino one is a good one. But yeah, thinking about that a lot. Okay, so that is the ESP-IDF update and segued into testing. So if you want to help me with manual testing, I'd really appreciate it, because I'm not a great manual tester. I don't think we want to merge it for 10.2 because I feel like we want to get 10.2 out before the IDF changes hit. Like there's embed TLS changes, and I switched to a couple APIs. But yeah, I think this is a really good characterization of how the way my work has changed. Of like, yeah, I was like poking and prompting Claude to do some of this migration stuff. Like I was getting, in the build errors, I was getting these warnings that I was using like an old flag. And so I just copied like warnings that said like, fix these, and I went and fixed them. Or like a warning about the old I2C API or the old touch API, and just fix this. So I like at a high level I'm directing it, but like I've looked at very little of the code. I've looked at the diff some to know that like I want to change some things, but like I didn't write a lot of the code. I was going back and forth a lot to do the Wi-Fi debugging, but still I wasn't doing a lot of the things, because like I do a lot of print debugging. And I can just say, Claude, add prints so you can debug this thing. And it can add debug prints for me. I don't have to do it myself. So it makes it very obvious that the bottleneck now is like reviewing and testing. And so, yeah, it's just, I don't know, maybe next week I'll work on that more. I've got BLE testing to do, which is a whole nother can of worms. But I think that the USB IP stuff is a really good platform for being able to do this remotely. I was even thinking like, oh, how would I test an implementation to bridge between USB host and USB IP on like an ESP chip? And it's like, oh, easy. I just say like, I've plugged in this thumb drive. Make it work, right? Like write the CircuitPython USB host mass storage driver until you can read and write a file, right? And then like, I don't know, like it's pretty clear when when that works. So yeah, I think it's really, really interesting. Okay, what else happened in Zephyr land? So let me just go through my things. So here's one I haven't pushed yet, but it's Zephyr Feather Sense. So Tim had asked for a build for the Feather Sense. It was quite straightforward. I based it on my work to add an NVM partition, because one thing I'm working on is like laying out partitions that work with CircuitPython, so that we can have like a bootloader and like particular designations of where stuff goes. This flash fixes branch got merged in. We can see that it's in Adafruit main. This was a bottleneck. Turns out that like the first pass of Claude writing all of the flash stuff seemed to work, but didn't work in all cases. In particular, a case where it used a 32-bit bit mask to know dirty blocks, but different flashes have different erase sizes, and you can fit more than 32 blocks in a single erase page. So I had to like prompt it for that, and it added tests in the native simulator too. So yeah, you have way less reason than before to not have tests with things. So those are coming down the pike. In here, oh, I was going to talk about this. So in this, let me move it to the right place. So in this branch in my YOLO work tree, I have Ethernet. So this might actually be an interesting study for LLM folks. And I actually think we could try it. But maybe let's let it keep going. Okay, so it doesn't look like it's not letting me go all the way back, which I wonder if it's doing compaction under the hood. But this is an Ethernet. I'm working on adding an Ethernet module to CircuitPython. So I wish I could show the whole history. I don't know why I can't scroll back further. But I basically said like, oh, I want to add Ethernet support. Look at how Wi-Fi.radio works. And then look at the Ethernet related APIs for Zephyr and espressif. And propose like an API to me. And oh, by the way, like, sorry, there. Fire extinguishing out my window. And then propose to me what the API will be. And oh, by the way, compare it to the Wi-Fi radio one. And it was just like, boop, boop, boop. I added all these parameters like IP address and all these things. And these are the ones that are shared with Wi-Fi radio, and these ones aren't. And it was like, okay, great, implement it. And so I told it to implement it. And now it's so weird that scroll back is limited. But now I had to implement it, and now I'm saying like, oh, like you think you're done, but actually what you need to do now is build them. So this is it doing the builds, and now it's trying to figure out how to fix them. And the source thing is blocking me for some reason. And I found this thing that tries to guesstimate how much money I have spent. So I'm on the top tier plan now, so I'm on the $200 a month plan. And so this gives you kind of an idea of, like, I think I spent almost $50 in tokens today if I was using the API. I was debating whether I should if I use the API, I think I can use the Pi thing, but the terms of service for Claude subscriptions say you can only use Claude Code. So I should say that I think I talked about here the fact that Claude Code has this remote control feature, and I was saying that I like got it working on my desktop but not on my phone. Well, that was my bad, because it didn't work on my phone because I was logged into a different account. So now I can actually like check in on my Claude sessions on my desktop remotely from my phone, which is really quite cool. So yeah, so this is now Claude kind of debugging its code that it was generated to try to get it fixed up. I was hoping to actually test it, but it doesn't look like it's building it. So we'll just let that run. What do I have in my OG? Picos. So I have another PR out. I have another pull request. There it is. All desktops, please. Another one of my pull requests. I've got a bunch. I did the flash fixes and then added some more. Dan's been a little busy, so he hasn't got back to me. But I have a pull request here for adding Raspberry Pi Pico builds. So this is meant as an easier way for people to test Zephyr on a board. Because the Raspberry Pi Picos have built-in UF2, they're great for that. All the RP2s do. So if folks have other boards you'd like to test the Zephyr board on, let me know. I think one of the big restrictions still is that we can't do dynamic pin mapping. So, you know, that's okay if you have a stem I squared C and it's just always I squared C. It should work. It should show up as board to I squared C, or whatever the name in the Zephyr board definition is. But I think that'll be kind of neat. So Pico support, and then I realized I had to change the priority that the CircuitPython thread ran at. I briefly was trying to get Wi-Fi working, and it's been a lot of Wi-Fi stuff this week, and that's kind of burned me out, which is part of the reason I was like, let me just kick off this Ethernet stuff, because it should be simpler, yeah, so in this Pico one, I do change the thread priority of CircuitPython. It was running it, so let's pull up a web page priority. Look at, it's even in my past searches. Zephyr thread priority. So I misunderstood the priority. So it by default runs at priority 0. So would the two WIZnet RP2350 plus RP2040 Ethernet ones work on Zephyr? Presumably not yet. Turns out they do have Zephyr support. The WW5500, or maybe it's 1W. Turns out they have Zephyr support. So I think that's my answer to the WIZnet stuff, is like, if it's built into the board, you just do Zephyr. So I actually ordered this one in the 2040 from DigiKey to just get it working. It does not offload it doesn't use socket offloading. It's done at the like raw low level part, but it does mean that like you get all the like SSL stuff too. So I actually did order those. I ordered a P4X board from DigiKey as well, which is like in theory, sorry, I know I'm a little scattered, but that's kind of my MO. The P4X board is out of stock, but I found it when it was, and you can see I purchased it, so it's on the way. Actually, it's not shipped yet. I don't know exactly why they've been delayed, but they have been, like high order volume, but I don't know why that is. But the P4X, I think, has a newer revision of the P4 function EV board with the chip revision 3.1 does not support secured download. Chip revision identification. So I'm not sure what chip revision I'll get, but they have this whole 3 series. Yeah, see, so like they have 0, 1, 1.3. I think there was a 0.1 as well. But I wanted to get this version 3 series. Let's take a look at that. Upgrade of, yeah, let's take a look at it. So the P4X is the way you can get, this is 2 revision 1.3. So wafer metal layer change. It optimizes the product's analog power design to enhance efficiency in low power applications. 1 to 1.3. But they are not talking about let's see if it's on the new website. I actually don't fully know what has changed in the version 3, but it's enough that they like put it on a different, they named the EV function board different. And I think that, here we go. This document describes the differences. 1.3 is Rev 301. I don't know. So let's see. Chip revision 3X. Features wafer level changes based on previous 1X version. I think they like updated the USB IP as well. The following bugs are fixed. The following modules are updated. The cores are updated so you can go from 360 to 400 megahertz, and then fix some bugs, improve dynamic clock gating, a new RISC-V extension. So this is why I was very keen on getting version 3 of the script, of the chip. Hardware loop counter width to 24 bits. Trace encoder, DMA, 2D DMA. IO hold during deep sleep for all IOs. Interrupt matrix. Yeah, so this is not just a metal layer, this is like a full new mask set. It added a different P384 curve. Key manager, random number generator. They added one. They improved the performance of the JPEG codec. Pixel processing accelerator, LCD, H.264 changes. USB 2.0 OTG high-speed, updated configuration to meet application requirements. Added description, up to 8 non-periodic transactions and 16 periodic transactions per microframe. That must be for high-speed host, I think. Oh, parallel I/O controller added a separate valid CS signal. CS signal no longer controls data transmission. Anyway, so, and they'd say that like you do actually have to change some hardware. You must upgrade to IDF 553 or 6.0. Yeah, so I was keen to get my hands on this new P4 chip. So that is another thing I picked up. I got lucky, and it was like they had four more on DigiKey. So I was doing an order for the WizNets and did that as well. So yeah, Picos are coming, NVM support is coming. I've still got BLE GAT support that I need to revisit, so maybe I'm done with Wi-Fi for a little bit, and next week is Bluetooth and Ethernet. And thinking more about hardware in the loop testing. I'm thinking like if I can put a hat. So this is an NXP dev board that I wanted to test Ethernet on. That's why it's got the Ethernet jack. But it actually has like an Arduino footprint, and I think what if I could put something on the Arduino footprint, loop over 2 USBs to go into USB host, and then just like power it like PoE. I don't know. For some reason, I like the idea of like just a Ethernet PoE thing to it. So yeah, that's what I'm thinking. Any questions? Anything folks are curious about that you'd like me to talk about for the last 20 minutes or so? I know I've rambled a lot about a lot of different things. What else do I have in the works? So the one way that I'm looking at that is my GitFourchette, just like the French thing. But it's really nice to give me an overview because I made it hide local branches that have been merged. So I can just look here and say like, oh yeah, IDF6 I'm working on, service server, that's the GAT stuff. Picos is out for review, NVM is out for review. Adaboot has a lot of changes that I've split some of them out. So like NVM is a prerequisite for the Adaboot stuff. I also think I want to put the Adaboot stuff in a separate repo so that like it's our kind of like you're using our UF2 bootloader with Zephyr. Here's the partition layout that everybody abides by. So I'm thinking about that. More USB IP work, which I am interested in doing. I think this stuff could get pretty far with Claude. So I'm tempted by that. RGB status, I was like, I still don't have NeoPixel support in the Zephyr build, so that's part of it. And then Zephyr Async IO. This is something I was thinking about this morning in the shower or last night or something. Like, I really am thinking a lot about, yeah, Adaboot is the equivalent of tinyUF2. tinyUF2 also provides partition requirements, but this would be Adaboot. My Adaboot is like, it's a fork of mcuboot. I guess we could call it UF2 boot as well. But the idea of like one bootloader for all Zephyr stuff that doesn't have native UF2. So RP2s don't count because they don't count for the bootloader side, but the partition layout, they still would. And we got to figure out like all the partition requirements, but getting the partition requirements documented well would be awesome so that you can like, when I was doing the Feather, like the Feather Sense was built on the NVM stuff, and the NVM stuff was built on, I was testing that on the regular Feather NRF 52840, and I could actually flash between Nordic port Feather CircuitPython and Zephyr Feather CircuitPython and like not lose NVM or CircuitPy. So I definitely want to do that sort of thing. So like having that well documented is helpful. And apparently you have to opt into abiding by the partitions, which was an adventure as well. Of like the Feather UF2 wasn't working originally because even though my device tree said that was the code partition, I hadn't like enabled the kconfig that said like no, follow that. So yeah. Analog IO, I'm looking here. I could get back to that. This Unity modules thing, I don't think I'm going to get back to. That was just more of a like, I said like, change the way this is built and how much code space do we save, specifically by putting Common HAL source code in the same translation unit as shared bindings source code, and it was only like 4K. It wasn't a whole lot, but it should be faster because you're skipping a function call. Analog IO I should get back to. That's another case of like, I gotta test it. And so really coming up with a way to do all these tests would be good. And then LVGL, I actually have like code that I had Claude generate to do display IO based on LVGL, which is still something interesting to me. This is built on, if we look here, it's built on an old version of the display IO changes. And so we'd have to get back to that. I'd like have to dust that off. But now's a good time to do it because with the display IO changes, I have native sim, and native sim has display tests. What tools do you have / need to test analog IO? It's the basics, right? It's like plug in a potentiometer and twist it to make sure that it changes. And I think one of the things that I didn't get back to analog IO for was figuring out how to be more pin dynamic. So we're not tracking pin in use at all. So like I hadn't learned. That doesn't sound automated. That's right. It's not automated. A lot of this is not automated, but like we should think about it. Tyeth, that is interesting. Thinking some FPC between the Feather, Uno, QtPy, PCB sockets, and the breadboard breakouts. Then you get DAC, ADC, INA 219. Did I probably haven't shown you this, but I did actually make this. Let me. You know what? Does the overhead work? No. Bench. You can see my Justice T. That's probably not any better than just doing the front camera. So I did make this board. So this is an adapter to go from the 40-pin Raspberry Pi header that the jumperless uses to the Arduino Uno pinout. And the labels here, it's designed to basically take the pin labels here and map them to the nano thing on the jumperless. And I haven't tested it yet, but this is like something I'm thinking about. And then here we have like which pin is which as well. So that was kind of fun. I haven't tested it, but yeah, it is something to think about. What about a digital scope and or signal generator or tools built off the off-the-shelf Adafruit hardware? Yeah, so I was thinking about this. I was chatting with Claude about, I'm like imagining something like this, but like you can just plug in an Ethernet PoE and then like put it on the board, and you'd have to plug in the 2 USB cords as well, but then you just like use that. Yeah, so I've been thinking about what you would want on that, and I think you can do a lot of it with the P4, but since I want to do this USB IP approach so that I can have native access to the USB ports, I can always put a hub, and if I put a hub, I can have like other devices that do more inspection, so like a debugger or a USB to UART. I could do that via a hub and then access it over USB IP, but or like I could do like a cheap micro that has USB, so like an RP2040, right? Like something I could load a digital scope or signal generator or like I2C test device onto. I could do that, and I could do that via hub until I want to cost optimize, and then I can make a virtual version in the P4 itself. Like, I'm not too worried about having, like, not having enough CPU cycles on the P4 to be able to do both, like, the USB host and the USB IP conversion. So I think it could also do things like, I was like, oh, like, if I want to have it do UART to USB, so that, like, I really like having two connections. One is for flashing and one is for debug output. And then the flashing one can usually switch between flashing and running CircuitPython. So I really like all these newer espressif dev boards where they have the two USBs. I love that. I love the two USBs. I got to figure out how to, like, pretend to do these buttons. But basically, like, the idea of, like, use multiple USB devices in concert via USB IP, and then, like, fold that functionality back into the, like, main microcontroller as a virtual device. So, like, right now I could plug in a USB to UART, Silicon Labs thing, do USB IP, and have it work, and then later make a generic one that does the same thing, but it's all just software on the P4, which I think would be cool. So we really want to cost optimize. I was thinking about this. So I have these Octoprobe tentacles, which is definitely, like somebody's really thought about these. I guess mine's in a further box. I'll get another one out. And I had these made, but they actually, I think they were quite expensive. They were like $50 a piece. And they still require you to, like, solder it down, which I'm kind of lazy about. But this is what somebody in kind of, like, more in the MicroPython community has come up with. And so this is the Octoprobe tentacle. It's got, like, one RP2350 for, like, flipping buttons on and off and doing sort of stuff, and then another one as a debugger, and then there's this, like, big area here where you solder to. There's a 40 pin here so that you can, like, chain them together, and it's got a built-in USB hub, and then you do, like, USB to your host. And so if you want a bunch of them, you do USB to all of them. And I just feel like I've been so burned by, like, 9 years ago, this was one of my first intuitions for CircuitPython, was like, we need good testing. And, like, I always had to go up and, like, unplug, plug it in, or, like, things would get into weird states. And so I don't know. I really like the idea of, like, doing it all over TCP/IP as a way of, like, really isolating a test device. And then I meant to look to see if the Ubiquity can actually, like, power cycle PoE, which I think it might be able to do. So if, like, it could automate that as well. And Lamore's just been talking about, like, and Tyeth have been talking about USB hubs where you can power cycle individual USB hubs as well. The other advantage of, sorry, that was loud. The other advantage of doing USB IP is that you can have multiple computers talk to it, right? Because it's just on the network. And the USB code that I already vibe coded for this, USB IP code, like, it does MDNS. Like, it just said, do MDNS so that, like, I can just do an MDNS query on my network and find all of the hosts, USB IP hosts. Yeah, hoping to mux to nano as saves pins on breadboard of jumper list, but not enough for larger pin counts. And ideally mux all the boards in along with components, not high-speed signals, though. Yeah, I think I was thinking about how many pins I want to cover, because I'd love to get pin mux stuff automatically. And I was looking at the Cybrain. Both the Cybrain and the micromods are kind of interesting. The Cybrain is this like standard from microelectronica, and it's like got these like high density connectors. Like it's got like a, I don't know, 300 pins that are broken out. They're quite ARM specific because they've got like specific SWD and trace stuff. But it is something to think about of like, I want to make a standard carrier board I'm going to use for automation. And then, yeah, interesting. Fully featured development board. Their stuff looks really nice. So this is one way we could get like a lot of pins out if we really wanted to for testing. But I think the right way to go is like, it's actually like, if I do feathers, I only care about the feather pins really. If I do, like, I could do those standard footprints as shields and then just pop them on, and now I can just test them. So yeah, I don't know. I'm thinking about it a lot. I'll come up with something. I think I do maybe want to poke the USB IP stuff next week, because I would like to start like doing some automated testing, like on device, as opposed to the stuff that I'm doing in, as opposed to the Zephyr native sim stuff, because it couldn't help me with the IDF testing. Like it would be nice on device testing would help me there. So yeah, if you have thoughts about hardware in the loop testing, let me know. Otherwise, I need to get back to BLE, and I'll test Ethernet. We can check Ethernet. Did it compile? It's not this branch. Nope. I think you could do 80 megahertz capture. No, it's still fixing the Zephyr port. Return the net mask of the first active address. Oh, and now it's going to do ESP. So yeah, I like, once this compiles, now I've got to actually like plug it in and try it. And, oh, I was thinking about that too. I think so. DCD is asking about this. Let me copy the link. It looks like the right thing. Oh, you can't see my desktop. Yeah, and I have the version 6. I think I've got version 6. Yeah, it's version 6. They're ordered assembled from JLC, which is great. And I think I had one, yeah, USB to Ubuntu. What USB chip is it? SMSC. Picoprobe, SWD. See, mounting it here, like, I'm quite lazy. Yes, I had mine built by JLC. Now let's see what Tentacle 7 does. Did they not tell me what the difference is? The power distribution. Yeah, so it's got 2 RP2s. It's definitely interesting to think about. Can we get to the heat guard, micropython? Where does this take me? I think I'm thinking something smaller and more Oh, they don't have them as releases. Still working on it though. Heat guard, I don't know what that is. Tentacle 071. It's not super clear. The ordering screenshots from JLC, I think, is something they did for me. Oh, swap screen, that's what you mean. I got there eventually. Yeah, basically other board, this board I did not do with JLC, but anything where I'm doing SMD, I'm just going to order it from JLC now. Like, in fact, when I'm looking at chips, I'm just like, does JLC have it? And I'm a little reticent to do the P4 because you have to do like standard assembly and not economy assembly or something. But yeah, the reason I did this is because it's all just like through hole, and I'm not going to pay for through hole. It's like literally just the 40 pin connector and some pin headers. But most boards I'll order with JLC PCB assembly because it's just miraculous to get a board you ordered with parts on it. It just like gets me over that extra hump of like I have to assemble it before I try it. Of course, this is assembled and I still haven't tried it. But I think actually, now that I think about it, the jumper list is probably better for that that case of like I want to test this with this. Whereas like most of what I'm thinking about now is like, how do I test it kind of like in a box or in an isolated fashion. Although testing Ethernet, like suddenly I'm back to like needing it connected to Ethernet. So I was thinking about that too. If they're Wi-Fi boards, I can just test the Wi-Fi with like I made custom SSIDs for 2.4, 5, and 6. Which task will trigger you to try out that board? Good question. The reason I made it, the thing I was doing when I did it was I2S support. I just threw that breakout board in a box. Yeah, but I2S support was merged in. I did test it on the IMX 1170 board. I did have to use some CircuitPython library to start up the codec, which is annoying, but it did seem to work, and it does work in the simulator as well. So another interesting thing about the native simulator stuff is that now as like code changes in shared module, we should add native sim. We should add tests that run with the native sim. It's an alternative to like the Unix port, but the Unix port is like more different. The nice thing about the Zephyr port between native sim and other boards is that it's like it's much closer in like implementation, in my book at least. So yeah, we're over our hour. Thank you all for joining. This has been another deep dive with Scott, where I ramble on for an hour about everything I'm thinking about. Thanks for hanging with me. I really appreciate it. If you enjoy that or not, and want to support Adafruit, you can go to adafruit.com, purchase hardware there. We're going to get rolling on some more dev boards. Lamore's been getting through her sensor backlog, and I think she's just about through it. So I'm excited to start doing some dev board work. Probably see some P4 stuff from us, so going to be in P4 land. Also excited to be on IDF6. Hold on. So that we can be with all the latest chips that we can get our hands on from espressif. And yeah, let me know how your LLM adventures are going in embedded land. I think I was thinking about this, there's a real opportunity for us to be trendsetters in the hardware in the loop world. And in fact, I should ask TAC about how he does it, because I know TAC has hardware in the loop testing for TinyUSB. So there's my brain dump. I'll keep you posted. I should be around next week. Thank you all for joining me on this deep dive. If you want to join the Discord, the URL is adafru.it/discord. DCD read my mind. Thank you, DCD, who usually does timecodes. And thanks to Tim for being another deep diver with me and filling in when I am on vacation or the kids are sick or whatever. So thank you all. I'll see you in the Discords, and should be deep diving next week. Join the Discord if you want to get notified if that doesn't happen. We have a deep divers role there. So thank you all. Have a great weekend. See you next week. And window cam is working. Little reflection, but sunny day. Pretty warm. Pretty nice. Bye all.